Hi there, I'm Nick Barraclough, the president at AKCP, and I'm delighted to share with you an update on our test data center facility. So it is taking longer than expected, but that's because we're also conducting science experiments here. We're not putting in a standard kind of chilled loop system that you would normally find in a data center. We're experimenting with some of our patented technologies. And so it is an iterative process. As we go along, we're finding errors in our design and fixing those and improving things as we go along. So it is progressing. All of the electrical work's done, as we'll see when we go down and take a look there. But we are now finalizing our pipe work and our network of valves and flow meters and telemetry so that we can properly run scientific experiments here. So let's go down now and take a look at the test data center and our progress so far. So here we are in our test data center with our hot aisle containment pod. You can see now we've added a lot of equipment up here that wasn't in our previous video. So what we've got now on each rack, we've got 3 PWMs. This is a pulse width modulator that allows us to control the amount of kilowatts of heat going to each one of the fans, so each one of the heaters. So we have 3 heaters in here, 9 kilowatts each, and we can control accurately now the number of kilowatts going to each one. So we could simulate, for example, a rack that had 9 kilowatts of load in the middle and only had 1 kilowatt of load at the top and bottom, for example. We also then have a VFD, which controls the speed to our fans, and we can therefore simulate a fan failure or a fan that's spinning slower than it should. So we can insert faults into the data center, and that allows us to test out our products such as sensor CFD and prove the energy losses and the air leakage that CFD can find. So this is pod 1 of our test data center. This is our hot aisle containment, meaning that all of the hot air that is being generated by the racks is being trapped in the middle of here. That hot air then circulates through our air handling units and we blow cold air out into the room. So the room is cold and the hot air is contained. We also have another pod that we're going to be setting up, which is the opposite of this. That's cold aisle containment. So we're blowing the cold air into the aisle and the room will be hot. So that allows us to test out different methods of cooling and operating your data center. In addition, in this pod, to the in-row air handling units, we've also got some unique overhead heat exchangers. So we can pre-cool the air as it comes out of there before going back to the fan wall, or we can also completely cool the air as it comes out of there by sending chilled water to the overhead heat exchangers. That frees up some space. You're not utilizing floor space then for the cooling units and the AHUs. Instead, you're able to put additional loads there with your racks, and we've shifted the cooling to above the pod. So here we are at the rear of the test data center facility, where we have our chiller and our filters. So this chiller is going to generate the cold water we're going to send back to the data center to use in the cooling loop. It is a closed loop system, meaning we have no adiabatic or evaporative cooling going on, so it's zero water usage. The water is simply circulated from here through these filters into the heat exchangers through a pressure tank, which provides us hydraulic separation before it comes back to here. If it is cool enough outside, or if we are operating with GPUs, for example, where we can have much higher return water temperatures than perhaps the chiller can take, we can also send the water to what we call our pre-freeze. Let's go and take a look at those. So here we have our pre-freeze units. These are basically dry coolers. We're sending the water from the data center back to here. We can then drop the temperature of the water to close to ambient air temperature, which here in the Philippines is around 30 degrees most of the time. But it does get down to 24, 22 degrees in the evening at some times of year. So what we can do then is drop the temperature of the water before we send it back to our water tank, which means that we don't have to turn the chiller on as often. So the chiller's job is basically to maintain the thermal mass at a specific temperature. So we have a tank of water and the chiller wants to maintain that at, say, 22, 23 degrees. The warmer the water we send back, the quicker it will be that the water temperature in that tank raises, and the faster it raises, the more soon that we have to turn on the compressor of the chiller. So if we can drop the temperature of the water here, it reduces the amount of load that we have to put onto the chiller. So we have a loop where we're able to send the water from the chiller to the tank, from the tank to the data center, from the data center to the dry coolers, and from our dry cooler pre-free units back to the tank. We also have one other loop where we're able to also cool the building and then use the waste water from cooling the building in our data center. So to cool the building, we need colder water. So we generate water at maybe 15 degrees and we put that through our HVAC system, which allows us to cool our office area. The water that comes out of there is still only around 20 degrees, which is plenty cold enough for our data center and plenty cold enough for a direct-to-chip cooling loop. So we can take the wastewater from the building into the data center before it comes back to our pre-freeze to drop it close to ambient before going back to the tank, resulting in a highly efficient closed-loop system, no water usage, no leaking of chemicals back into the environment. And it's really quite a nice setup that we've got here in our test data center facility. So if you've got this far in the video, thanks for sticking with us. I hope you found it informative, and I am excited to share with you genuinely all of the updates from AKCP. Please do like and subscribe, follow us on our YouTube channel and also on LinkedIn, where we're quite active, not only with AKCP products, but also with general data center, daily news, and how it affects you and your operations and your facility. So thanks for tuning in, and I'll see you next time.